On this 2019 to 2024 Ram 1500 Classic with the 5.7 Hemi P0325 is a knock sensor 1 circuit code. In plain language, the PCM may be seeing the knock sensor signal out of the range it expects. The truck may only show a warning light, and the fault area can be the signal circuit, the return circuit, connector condition, the sensor itself, or in the end, the PCM. Before going into pinpoint testing, start with the basic system checks. Then reproduce the operating conditions for the code and see whether P0325 is active or pending. Start the engine, test drive or operate the vehicle under the monitored conditions, then read and record the codes with the scan tool. If the code is not active or pending, treat it as an intermittent condition instead of forcing the rest of the circuit test. For the monitor gate, this check runs with engine speed above 2000 RPM, battery voltage between 7.5 volts and 15.8 volts, and barometric pressure above 75.2 kPa. The code sets when the PCM detects knock sensor input voltage above 4.8 volts or less than 0.2 volts when engine speed is above 2000 RPM. The MIL will illuminate when this fault is present. If P0325 is active or pending, move to the knock sensor 1 signal circuit. Turn the ignition off, disconnect the knock sensor harness connector, then turn the ignition on. Measure voltage on the K42 knock sensor 1 signal circuit at the knock sensor harness connector. If that circuit is above 5.2 volts, repair the K42 signal circuit for a short to voltage, then verify the repair and confirm the code stays gone. If it is not above 5.2 volts, continue with the open or high resistance checks. Next, turn the ignition off and disconnect the PCM C2 harness connector. Do not probe the PCM harness connectors directly. Probing them can damage the PCM terminals and create poor terminal-to-pin contact. Use the GPEC Diagnostic 10436 adapter for this diagnosis. Measure resistance in the K42 knock sensor 1 signal circuit from the knock sensor harness connector to the GPEC adapter. If resistance is below 3.0 ohms, the signal circuit passes this part of the test and you move on. If it is not below 3.0 ohms, repair the K42 signal circuit for an open or high resistance, then verify the repair and confirm the code stays gone. With the adapter still in place, check the K942 knock sensor 1 return circuit from the knock sensor harness connector to the GPEC adapter. The same pass point applies here. Resistance should be below 3.0 ohms. If it is below 3.0 ohms, keep moving down the diagnostic path. If it is not below 3.0 ohms, repair the K942 return circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. Now check whether the signal and return circuits are shorted together. Check continuity between the K42 knock sensor 1 signal circuit and the K942 knock sensor 1 return circuit at the knock sensor harness connector. If there is continuity between those two circuits, repair the short between the signal and return circuits, then verify the repair and confirm the code stays gone. If there is no continuity, go to the short to ground check. Next, check continuity between ground and the K42 knock sensor 1 signal circuit at the knock sensor harness connector. If there is continuity to ground, repair the K42 signal circuit for a short to ground, then verify the repair and confirm the code stays gone. If there is no continuity to ground, the circuit checks in this path have passed, and the next step is the sensor retest. At this point, replace knock sensor 1. Reconnect the knock sensor and PCM harness connectors, turn the ignition on, and erase the codes with the scan tool. Then operate the vehicle under the captured or monitored conditions that set the code and read the codes again. If P0325 does not return, the knock sensor 1 replacement repaired the fault, and you still finish by verifying the repair. If the code returns, continue to the related connection checks instead of guessing at the next part. If the code came back after the sensor retest, inspect the related harness connections. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Look for connector installation problems, damaged locks, corrosion, water intrusion, weather seal damage if equipped, bent terminals, heat damage from a poor connection, terminals pushed back in the cavity, spread terminals, and poor terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure everything is fully seated and the locks are engaged. Erase the codes, operate the vehicle under the monitored conditions, and read the codes again. If P0325 does not return after the harness and connector repairs, the wiring or poor connection problem has been repaired. If P0325 does return at this point, the diagnostic path calls for PCM replacement and programming, followed by repair verification. Keep verification separate from the testing. Clear the code, run the vehicle under the required conditions, and confirm the code stays gone. The takeaway is simple. Prove the knock sensor signal and return circuits first, protect the PCM terminals during testing, and only move to the sensor or PCM after the circuit path has been checked in order. For more diagnostic training, visit stepdiagnostics.com.